Hey friends, welcome back to another video. Today we are diving deeper into Ingress in Kubernetes. Let's see the agenda first. First, we will explore the important methods for exposing an application running on Kubernetes cluster to the external world. Some of these methods include Nodeport, Load Balancer, and Ingress. So the Nodeport, we will explore how the Nodeport works and understand its drawback at the high level. On the load balancer side, we will take a high level walkthrough of the load balancer and explore their limitations. On the ingress side, we will understand the ingress in detail. In the ingress, we will understand the main components like ingress resource, ingress controller, and understand how it's work within the Kubernetes. Then we will explore the prerequisites for exposing a Kubernetes application through an AWS application load balancer using Ingress. Finally, in a demo section, we will expose the application through Ingress in a EKS environment. Before we explore Ingress further, let's first understand the problem it aims to solve. Let's try to understand with an example. Imagine you have a big clubhouse with lots of different rooms for various activities. Now this clubhouse is your Kubernetes cluster. Your friends coming to attend a party in the clubhouse, which is a traffic from internet to the application running inside the Kubernetes cluster. You have an application running in your Kubernetes cluster and you wanted to share it with your friends and others outside the Kubernetes cluster through the internet. Now, there are few ways you could do this. You could open the clubhouse door wide open, as same as using the Nodeport, or you could create a special window for everyone to peek through. That is like creating a service of type load balancer. Another way is to have a friendly guide, that is Ingress, who helps direct your friends to right place inside the clubhouse without giving them access to all the rooms at once. Let's go through these examples service type a little deeper. First, let's check the node port at the high level. When you are using node port, you are basically assigning a specific port on the host machine to your service. So when your friends, that is a traffic, come knocking at the clubhouse door, which is your host machine, they are directed to the right room, which is a service inside. But imagine if you have a gigantic clubhouse with hundreds of rooms or services to manage. It would be like having to remember which friends goes to which room every time someone knocking the door. That is a lot of work and can get pretty chaotic, right? That's why in the case of Kubernetes with a lot of services to manage, relying solely on Nodeport would be like trying to remember all your friends' room number in your huge clubhouse. That is not just practical. So let's check the load balancer at the high level. Creating a service of type load balancer is another way of exposing your application to the internet. It is like having a dedicated gatekeeper or load balancer at the entrance for your clubhouse who direct traffic to the right room, which is the service inside. However, there is a catch. Every time when you create a service of type load balancer, Kubernetes goes ahead and set up a new load balancer just for that particular service. It's like having a separate gatekeeper for every room in your clubhouse. Imagine if you have a huge clubhouse with lots of room, that's going to cost us a lot of money. Plus, in clubhouse with microservice architecture, where you have different applications or rooms that needs to be accessed through the same main door or domain, it get even trickier. You want your friends to be able to come to the clubhouse and say, I wanted to go to example.com/customer room, and the gatekeeper, that's a load balancer, should know exactly where to send them. But with the current setup, each service of type load balancer creates its own gatekeeper. So routing traffic for same domain or subdomain to a different load balancer become impossible. It's like having too many gatekeepers at the same entrance and they don't know which front goes where. That's where Ingress comes into the rescue. It's like having a super smart guide who can direct your friends to the right room or service inside the clubhouse, all while you just using one main entrance. It's more cost effective and make things a lot simpler for everyone. So what is Ingress? How does it work? Ingress is a Kubernetes Ingress in Kubernetes act like a traffic controller for incoming connections from outside the cluster. It's an API object that helps manage the external access to the service running inside the cluster. By setting rules and configurations, Ingress ensure that inbound connections are directed to the appropriate services based on defined criteria. This helps streamline the flow of traffic and ensure that requests from external sources reaches the correct destinations within the Kubernetes cluster. Let's go back to our clubhouse example. Ingress like gatekeeper at the entrance of your clubhouse. This gatekeeper equipped with the sign and instructions help the visitors from outside find their way to the right room inside the clubhouse. For instance, if someone wanted to play game, the gatekeeper direct them to the game room. If someone wanted to read, they guide them to the library room. Similarly, if someone wanted to chat, they will direct them to the launch room. In Kubernetes, external traffic is similar to visitors coming to your clubhouse. Ingress like gatekeeper ensure that external traffic is directed to the appropriate service or room within the Kubernetes cluster based on predefined rules and configurations. Just as gatekeeper ensure that the visitors find their way to the right room in the clubhouse, Ingress ensure that external requests find their way to the correct services in the Kubernetes cluster. It acts as a friendly guide, facilitating smooth traffic flow and efficient access to the service within the cluster. Let's check some of the main features of Ingress. First one is external access. Ingress allows external traffic outside the Kubernetes cluster to reach inside the service. Second is routing rules. Ingress define routing rules, specifically how incoming requests should be directed to different services based on criteria such as hostname, path, or header values. Third one is load balancing. Ingress can be configured to distribute incoming traffic across multiple backend services, ensuring load balancing and high availability. TLS termination. The Ingress support TLS termination, allowing it to terminate SSL or TLS connections and decrypt the incoming HTTPS traffic before forwarding it to the backend services. We will see these features in the demo. There are two primary components for Ingress. First one is the Ingress resource. Ingress resource is a Kubernetes object that defines how inbound traffic should be routed to the service within the cluster. It specifies rules such as hostname, path, and backend services. Ingress resources provide a way to configure traffic routing without modifying the individual service configurations. Ingress defines routing rules for incoming and specifies how requests should be directed to different backend services. Say example.com/customer goes to one set of ports and example.com/product goes to another set of port. In summary, Ingress is a Kubernetes resource that defines the rules for routing external traffic to service within the cluster. The second main component is the Ingress controller. An Ingress controller is Kubernetes software component responsible for managing and processing Ingress resources. It acts as the implementation behind the Ingress API and is responsible for configuring and managing underlying infrastructure such as load balancer or reverse proxies to route external traffic to services running within the Kubernetes cluster. In essence, Ingress is a specification or configuration defining how traffic should be routed, while Ingress controller is a software component responsible for implementing and enforcing these rules within the Kubernetes cluster. If you are enjoying this content, please consider liking the video and subscribing the channel. Your support encourages me to create more video like this in the future. Let's log into the AWS console and install Ingress and the load balancer controller. So first let's go to the EKS cluster and review the cluster. So I have a cluster called the demo cluster, and on that demo cluster I have a node group called the demo group. Then I have an EC2 instance running on that particular demo group. So this is my structure. So this is a new cluster. Let's add the user to this cluster and provide the access. So add the policies. Okay, so I have an EC2 instance which I'm using as a gem server to connect to this EKS cluster and installing the Ingress controller and the load balancer. So let's go to the EC2 instance, and this is my gem server. Connect to the gem server. So login as root user and just check, just update the profile. So the configuration is updated. Let's check whether I have access to the cluster. Okay, I have access. So now to install the load balancer controller and ingress controller, I have documented all the steps in the GitHub repository. I will link the URL in the description below. So let's review the step here. So first step, as a first step, you need to create an OIDC provider. Let's go ahead and copy this command and run it. So this will create an OIDC provider. So this is for the authentication from the cluster. So that is done. Second, you need to create a you need to add a tag for the internal load balancer. You need to create role internal ELB, and for the public load balancer you need to add role ELB. There is no internal in the public ELB. So I have already added that here. Let's go to the VPC and confirm. Sorry, go to VPC and the subnet. On the public subnet, I have a tag called role ELB. So I'm using a public load balancer. So I have added that. And then next step is I need to download this IAM policy. So copy the URL. So download the policy and create the IAM policy. Okay, the policy is created. Now using this policy we need to create a role and a service account. Let's create that. This service account, the load balancer controller will be using the service account to control the load balancers. Let's wait for this to complete. Okay, that is completed. Now let's go to the next step. So this is a step for installing the load balancer controller. First we need to add the Helm repository. Just add this repository. Okay, just update the repository. Okay, now install this controller, load balancer controller. Okay, so the load balancer controller is created. Now let's just verify the controller is running. Okay, so two ports are ready, so it is running fine. Now another step is we need to create an ingress, and through the ingress we'll verify whether it is creating the load balancer and it is health check is getting succeeded. To create ingress we need we have a YAML file and the deployment.yaml file. There our kind is ingress and we are actually using the name as Nginx. On the annotation section, we are actually giving more details where we are specifically provided load balancer name as ingress test and the schema as internet facing and the target type is IP. So we are listening on the port 80 and 443, but on the 80 we are redirecting to 443. And on the default action, we are 503 action, we are actually sending a message unknown host. And we are using for the HTTPS, we are using the certificate and then the security group, this specific security group, which is accepting traffic from the external world internet. And on the spec section, we provided the ingress class as ALB and as usual the rules which is which mention the what is a host name And then on the path we have SSL redirect. This we need to use this annotation for or this section for in the ingress to direct correctly set the HTTPS configurations. So if it is HTTP, we don't need to use this one. And then we have two paths. One is customer and another is product. The customer is going to the customer service and the product is going to the product service. So let's first review the service part, then we'll come back to the deployment. So the product service, we have it is listening on the port protocol HTTP, and it's checking the health check. These are all the normal health check configurations. And then on the selector, we are using the selector as product, and the name, which is a product, that is actually used in the ingress configuration as a product, or sorry, the service name. Okay, and then the same configuration for customer as well. Then let's come to the deployment. We have a customer deployment. There we are actually using the Nginx. So it's not an actual real application. Nginx is used to demonstrate how we can install the Ingress controller. Let's copy this. Create a file. Okay. Apply. Before even applying that, let's check whether there is any load balancer. So there is no load balancer. There's no target group. Okay, let's apply this. Okay, it's created the ingress, it's created the deployment, and it's created the service as well. Now let's come to the load balancer. See the name with the ingress test is getting created, and the target group, let's see how many targets. See, there are two target groups. And when it comes to the load balancer, let's see the listener rules. It's created a rule on 80, which is redirecting from HTTP to HTTPS. And then on the HTTPS section, we have rules for routing traffic, which is coming to fasttrack.ed.com /customers. It is redirecting to this specific target group. And then the /product or anything starting with product is redirecting to the another target group. So anything which is not matching with the path pattern is actually giving a 503, and anything which is coming, any other request which comes, it will give a 404. All right, let's wait. Let's go back to the target group and see the health check. So we have configured the index.html. Let's confirm that. So goes to the service side. See that index.html we have configured there. That is already here, and all other details which we already configured through the configuration file of Kubernetes is already there. So let's wait for the health check to pass. Yeah, also one more thing on the load balancer side, we need to check whether the SSL certificate is being configured. So go to the certificate and see that, yeah, the certificate ID is there. So that means its certificate is also configured properly.